Welcome to today's webinar, Enabling Next-Gen Cybersecurity with Radware and Big Switch Networks. My name is Angelique Medina. I'm the Senior Product Marketing Manager here at Big Switch, and I'll be your host for today's webinar. We're very excited to be joined by Radware today, and our panel is Dennis Uzlay, Director of Security Solutions Architecture at Radware, David Jimenez, Security Solutions Architect at Radware, and on the Big Switch side, we have Bala Ramachandran, Director of Product Management, and Ted Elhurani, Technical Marketing Engineer. So before we get started, I just want to run through a bit of housekeeping. So to the right of the screen on the webinar dashboard, you'll notice a Questions tab. And as we go through the presentation, please feel free to ask questions. At the end of the presentation and demo, we'll have a brief Q&A session. If you're watching this video on demand and you have a question regarding today's topic, simply go to the bigswitch.com/webinars webpage and submit a question using the link provided. We also have provided handouts for today's session, including product information on Big Monitoring Fabric, plus some information on Big Switch Labs, and you can access these from the Handouts tab. So with that, we are going to turn this over to Dennis. Dennis, welcome.
Hi, this is Dennis Uzlay, and thank you for the introduction. As you mentioned, today we will be overviewing the Radware Big Switch partnership, integration of our DefensePro Alteon SSL decryption, encryption capabilities, and the Big Switch Networks toolset. Before we jump into the integration, we'll go through a brief introduction to Radware and the different technologies we bring to the table. Then we'll step into the integration itself. Next slide, please. So a quick few words about Radware. Radware is a market leader in both cybersecurity and application delivery. We've been recognized by Gartner and others for our technology innovation, as well as our services and excellence in customer experience. We are a very stable company. We're traded on the NASDAQ, and we have great experience with most household names. As you can see some samples of our customers on the screen here today. We've expanded from the enterprise through cloud and carrier service providers. We have wonderful technology partnerships with Big Switch Networks and some of the others you can see on the screen here today, some of which OEM our technologies, others of which are pure play partners. And we're happy today to dive in with Big Switch and yourselves. Next slide, please. So what Radware brings to market is, as I mentioned, two core focus areas. We have our cybersecurity with integrated attack mitigation from premise to cloud-based DDoS and application security protections. These include a premise-based equipment, which can be virtual or physical and extend out to the cloud for protections in DDoS, as well as web application security and malware protections. On the application delivery side, we have a next generation application delivery recognized by Gartner as a leader in the quadrant. We are delivering applications for, as I mentioned, some of the largest companies in the world, providing application compression, acceleration, and visibility tool sets to these environments where we can provide inbound and outbound SSL, our TLS encryption and decryption capabilities through traffic steering and the ability to provide your tools in the environment with clear text visibility. Next slide, please. So as we look at our attack threat landscape today, I'd like to go over this briefly with you. As we see it, the landscape has expanded significantly over the past several years. And even more so in this year in 2017, we have the rise of the botnets, which has really expanded and enumerated the volume and increased the complexity of attacks. What we're seeing in our analysis of customer mitigations is that attackers are now leveraging easy-to-use tools. They have a wealth of tool sets available and very low economics. It's relatively easy and simple to and cheap to gain access to tool sets that can cause havoc to a destination or target. And a lot of these campaigns are motivated, in which they are targeted in bringing down a specific company or resource, what have you. What we see in these attacks are multiple vectors. These attacks are targeting their destination, and they will take any which means to the end to reach their ultimate outcome, which is usually to cause an outage or smoke screen for a potential exploitation of sensitive data. If we can play out the slide just a moment, you'll see here the various different vulnerabilities in the environment. We have the internet pipe, the firewall, and IDS and IPS. All of these are typical suspects for becoming the bottleneck inside of a DDoS attack. And you'll note that your firewall and IPS are sometimes considered to be your security tools, but these are the exact same tools which are vulnerable to such an attack. What happens is the state tables fill up on these devices and they tip over, often requiring reboots to bring back online. And this goes down into the network, obviously, in the application delivery controllers, load balancers, the servers themselves, and the applications. We at Radware recognize this multi-vector attack trend, and we bring to bear a complete solution set, as you can see below, from cloud DDoS protection to handle the internet pipe saturation, the on-prem component for handling denial of service on site, providing visibility into those encrypted attacks, and using our patented behavioral protections to keep the applications and network online without bringing down the legitimate traffic, which is the key to success in any successful attack mitigation. Followed by the IPS engines, which provide the known attack capabilities, known vulnerabilities and signatures, the SSL providing that visibility to the encrypted attack, and then finally the web app firewall providing full capabilities for application layer protections and providing a behavioral engine that can adapt to the changing threat landscape. Next slide, please. So what I mentioned were generics. In the previous slide were the cloud DDoS, the DOS protection, behavioral analysis, IPS, SSL, and WAF. These are the categories in which we believe you need to be protected. And below that, we can see the specific product sets that Radware brings to bear to help resolve these threats. So we offer a cloud mitigation service to our customers, as well as the on-prem, and the ability to signal between devices. So for instance, a premise-based device can signal out to the cloud and provide a seamless mitigation while transferring our known baselines and legitimate traffic values out to the cloud. We provide that seamless transition without needing to relearn the environment and providing the best possible mitigation. In addition, we have our application delivery and web app firewall capabilities, which also signal into the environment, providing a complete ecosystem of attack mitigation. On top of this, we have our emergency response team, who is available 24/7 to handle attacks with our customers, and our centralized management and orchestration systems to enable a single pane of glass and attack lifecycle orchestration. Next slide, please. What we're going to showcase today is our Radware Defense Pro. Defense Pro is a inline or out-of-path application and network security device that can provide availability to the environment. This tool is purpose-built. It's available in both 200 meg through 400 gig of traffic inspection capabilities, and can provide the on-premise mitigation for the environment. The tool is licensed based on legitimate traffic inspection. Next slide, please. So Defense Pro brings to bear multiple different innovation capabilities from Radware. We offer from application and server and network layer protections, providing layers 3 through 7 attack coverage for even the most recent threats today. Some of you may be aware of the Mirai botnet attack and the damage it caused on Dyn DNS and the many different customers that were impacted by them, as well as Brian Krebs and many, many others. Radware brings this behavioral algorithm that can not only detect but automatically mitigate these threats in real time with our behavioral detection and mitigation. That brings to discussion around our real-time signature capabilities, the ability to zero in automatically to identify 0-minute attacks. We have challenge and response capabilities to weed out the dead actors, essentially identify bots and allow only the legitimate traffic to get through. Access control handling for rate limiting and white and blacklist and geo-IP. And finally, we have the IPS covering those known vulnerabilities and attack tools. It's a layered approach that is really unmatched in the industry and allows us to keep our customers online. Next slide, please. So our behavioral-based detection is really unique. We rely on a full packet analysis of the traffic passing through or copied to the device, and have the ability to zero in based on not only rate differentiation but also on a rate invariant. So, for instance, when we look at not only a rate of traffic arriving to the network, we can look at that rate invariant and identify when there's a true attack versus a successful marketing campaign or flash crowd of traffic. This prevents false positives and provides a very good user experience when passing through these mitigation appliances. A note that the same device is doing the detection and mitigation in this use case. Next slide, please. Once we've actually detected an attack, the Defense Pro has this capability of building the real-time signature that I mentioned for 0-minute mitigation. What that means is we're actually analyzing the traffic in a closed feedback system that can identify the specific parameters of the attack that are considered an anomaly and put a footprint or real-time signature to mitigate that attack specifically and allow the legitimate traffic to come through. This is an IP agnostic capability, which effectively doesn't require to block based on source IP. So what that means is you could essentially have legitimate users that are participating in a bot that could potentially also be browsing your website to purchase, for instance, within the store site. And this capability would provide you the ability to accept their payment and block the botnet traffic that they're attacking you with. This is really unique. It's what separates Radware from the rest of the crowd in the DDoS space, and it is automatic. It is removing the time that it takes under a very high stress environment, under an attack. What it would take in other tools to write a signature, custom signature, we are doing automatically in a matter of 18 seconds or less. And with that, I think we will now move on to Bala, who will open up the demo and get us started into the integration. Thank you, Bala.
Thank you, Dennis. That was a great overview of the Radware products, and it's great to see how Radware is helping to tackle modern world security problems with a portfolio of industry-leading products for DDoS mitigation, for SSL visibility, and so on. So as you pointed out, we are increasingly seeing the need for scalable security in the data center. So that is where, Big Switch and Radware have collaborated, and they're working together to offer end-to-end pervasive security monitoring solutions in the data center. And so we'll be looking at two deployment scenarios today in terms of the solutions. One is out of band within the data center, and another is inline at the data center DMZ. And for the demo purposes, we'll be focusing on the inline use case. But let's dive right in and first look at how Big Switch and Radware are collaborating on the data center monitoring solution. So we're seeing tremendous growth in the traffic in the data centers, and the bandwidth needs are getting larger. They're evolving from 1 gig, 10 gig to now 10 gig, 25, 40, 100 gig. And the majority of this increase is driven by intra-data center traffic between servers in the data center. So monitoring this increasingly dynamic traffic is a very difficult task for enterprise IT. So cybersecurity is also another huge driver for monitoring in organizations, which is where our solution with Radware is really going to help the organizations. So cyber attacks are increasing in volume as well as complexity. So what this means is that there's a compelling need for monitoring traffic across the data centers, not just at specific points in the infrastructure. And a typical network packet broker is deployed to aggregate filters, replicate traffic, and so on, and it goes to tools. But traditional NPBs are complex, they're expensive, they're proprietary boxes that restrict the scale of monitoring because costs are prohibitive. They're operationally challenging because of box-by-box management, and they also cause tool silos. As more of the boxes are needed, discrete units are added, so that causes tool silos. So what we have with this solution is Big Monitoring Fabric, or Big Mon in short, which offers a next-generation packet broker capabilities. So essentially, the Big Mon fabric is a fabric of 1, 10, 25, 40, 100 gig switches made by managed by a pair of controllers. But the fabric itself is, composed of open networking switches from Dell, HP, Alteon, and the switches run what is called a Switch Lite OS, which comes from Big Switch, and the controller is an SDN controller which manages this entire fabric. And the key insight is the fabric is abstracted as a single logical switch to the controller. And the fabric can be scaled out in a very automated fashion. So as you add more switches, it is still viewed as a single logical switch from the controller. So, the controller accesses the single pane of glass for control operations. So it tremendously simplifies operations because of that. And due to this unified management approach, you no longer have tool silos. Essentially, it is, all these, if you look at the solution here, the Radware tools, the DDoS DefensePro tools are aggregated in a central tool farm, and it is connected to the single logical network packet broker. So with this automated and extensible architecture, what we have pioneered are some very unique use cases where every rack in the data center can be tapped and spanned to send copy of production traffic to the monitoring fabric from any workload running on the physical servers, or or it could be VMs or containers, and tools can be aggregated in the centralized tool farm, and with the functionalities that can be configured from big mon controllers such as packet filtering, aggregation, load balancing, packet replication. NetOps and SecOps teams can ensure that the right traffic is sent to the right monitoring tool. So this ensures optimal and intelligent usage of tools while simultaneously expanding the scope of monitoring. Another important component of the solution is the big mon service node. So it is a DPDK-based x86 appliance, again managed by the same controller, so the user has a very seamless operational experience. And this service node provides advanced functions like regular expression matching, deduplication, slicing, header stripping, net flow, and so on. So all of these features, which again enable tool efficiency by sending them the most important and interesting traffic for monitoring. So now let's look at the DMZ, which is the other use case I was talking about. And our focus of the demo today is again going to be on this solution. But let's look at what is the problem first of all in the DMZ that we are trying to tackle here. So some of the key issues when deploying security tools at the DMZ or the extranet is that you typically have a slew of these tools deployed because DMZ is a gatekeeper, right? And you potentially need to chain multiple of these tools. For example, you have firewalls, you have the DDoS devices, you have the SSL visibility appliances, you have IPS, web proxy, different tools doing different functions, right? So traffic needs to go through multiple of these tools. In addition, different types of traffic need to go through different set of tools, which in other words means that there's a need for creating multiple different tool chains. And people have tried to use existing technologies like policy-based routing rules to steer traffic across the tools, but they are complex. It's hard to use, and it is very difficult to create dynamic service chaining logic with such methods. So with this kind of an infrastructure, it also gets very hard to add more tools. It's difficult to load balance traffic across tools, and there's no easy way to detect tool failures. It's hard to reroute traffic on tool failures, and last but not the least, the solutions are expensive to implement and cumbersome to configure because they're box by box. So these limit tool efficiency, create a lot of operational challenges. So solving all these issues needs rethinking in terms of an architecture with a different software-based approach. And this is where we have the big mon inline solution with Radware, which answers a lot of these problems. The solution uses an SDN-based approach to tremendously simplify and manage dynamic service chains. And it is also done at a very affordable cost by leveraging the same industry standard open networking hardware that I talked about in the out of band the data center solution. And the big mon inline solution uses the open networking switches from Dell, HP, Acton again, right? And it runs the same switch lite operating system, and it is also managed by the big mon controller, which acts as the central point of control configuration. So the controller configures multiple policies on the switches to create different traffic paths through the inline tools. So because of this capability, you are able to really link together multiple tools in the chain in a very dynamic manner, and you can steer specific traffic through specific set of tools based on user matching criteria. So in this case, for example, with Radware, you could have the SSL encrypted traffic go through the Alteon SSL inspection tool and the DefensePro DDoS tool, while you may want the non-SSL traffic to bypass the SSL inspection tool. So by doing this, you're really improving the efficiency of the SSL tool by sending only the interesting traffic to it. And you can also have a service chain with one set of tools upstream, another set of tools downstream. You can have chains configured as unidirectional or bidirectional. So a lot of flexibility, a lot of cool features. And creating and modifying service chains by adding, removing, bypassing tools to the security chains can be done with a very intuitive drag and drop GUI with just a click of mouse, right? And essentially it makes it really easy for our customers to build out this scale out security chaining, which really differentiates our solution versus the other solutions that are available in the market. Now, advanced features like health check is available for tools, making sure services are available and making the architecture very resilient. So if a tool goes down, BigMon automatically switches over to the redundant HA path through the other tool instance. In addition, certain tools like firewalls may be marked as mandatory, while others can be optional in the chain. So if a tool is optional, it can be skipped in the tool chain if it is down. So in summary, this BigMon Inline with Radware portfolio of products provides a very scalable, reliable, state-of-the-art security solution that is extremely simple to deploy, very affordable, and with the new normal being constant re-architecture of DMZ for evolving security threats, a dynamic SDN-based solution like this one with BigMon and Radware is the real answer for your for really securing your DMZ with a variety of these devices. So one of the capabilities that will be showcased in the demo, and it is easily implemented with BigMon Inline, is the ability to load balance traffic across multiple Radware DefensePro DDoS devices. So when this capability can be combined with the seamless service chaining with other Radware tools, can be a very powerful security solution, especially as it allows to auto-scale DDoS mitigation tools as the capacity needs increase or the volume of traffic increases, essentially. Also, since this is a bump in the wire solution, traffic can easily be re-injected back into the chain without any problem. The other use case that Ted will talk about today is in the demo is the BigMon Inline solution with the Radware Alteon SSL. So the BigMon Inline switch, in this case, right, it sends SSL traffic to the Radware Alteon SSL tool, which decrypts the content and it sends it out to the BMF inline switch that is connected to it, right? And then the inline switch then sends the decrypted traffic to we could chain it to an IPS or the Radware DDoS Defense Pro devices, right? And which will inspect it for malware. In case of Radware DDoS, it can do L7 inspection of the traffic. Now, if the decrypted traffic is not blocked or dropped by the inspection device, it is returned back to the inline switch. It is then sent to the SSL tool, which completes its task for the outbound direction by encrypting the traffic and sends it back to the inline switch. So the packet is then sent out to the internet or into the production network depending on the direction of the flow. And as you can see, this solution allows for a very dynamic service chain capability where you could chain multiple security devices, Radware Alteon with Radware Defense Pro, or you could chain it with other IPS devices and really leverage the capabilities of the solution to offer the best-in-class security in the DMZ. So just want to finish with a quick summary of the key value propositions of the solutions that I talked about. First of all, it's open vendor, as it leverages open networking hardware, and it prevents vendor lock-in, and it leverages SDN. So It offers a tremendous operational simplification because of that, as you have a single pane of glass, and it's a pay-as-you-grow flexible model, and SDN enables you to abstract the entire solution as a single logical unit. And the SDN controller allows for automation, agility, simplicity, a lot of visibility benefits. And finally, you have the analytics, right? Real-time historical analytics, which is offered as part of the solution, with which you could get deep network visibility into the production environment. So with that, pass it on to Ted for a demo where you will see all of this in action, and we have a very cool demo plan for you today. Thanks, Ted.
Thank you, Bala. Before we dive into the demo, we will briefly go over the topology. For this demo, we have the big monitoring fabric controller providing control and management of a switch deployed in inline mode. The inline switch is connected to the WAN or untrusted zone and to a web server through the data center network. Our goal is to allow for seamless and transparent chaining of inline, bump-in-the-wire tools to protect the web server against threats coming from the untrusted zone. We therefore attach Radware's Alteon SSL appliance to the switch, as well as 2 instances of Radware's Defense Pro for DDoS detection and mitigation. In the demo, we will show you how the Big Mon chain sends SSL traffic to the Alteon appliance to create a decrypted traffic zone. We will use Wireshark to look at traffic inside and outside this decrypted traffic zone. And then we will also launch a DDoS traffic in the form of TCP SYN attack and show you how Big Mon load balances traffic across the 2 DefensePro appliances to mitigate the attack. First, let's take a look at how we configure the chain on the Big Mon controller. The logical chain is defined on this GBMF inline switch. Ethernet 5 is connected to the untrusted zone and Ethernet 6 to the web server we are protecting. We first have the Radware Defense Pro inserted in the chain, followed by the Alteon appliance that is logically represented as 2 inline services. Incoming traffic from clients in the untrusted zone is received on Ethernet 5 and will first be sent to the Defense Pro. After it performs its function, the Defense Pro will return the traffic to the inline switch. Traffic then will be sent to the next service in the chain, the Alteon appliance, which will decrypt the traffic and pass it back to the inline switch. To re-encrypt this traffic, the switch will return the traffic to Alteon 2, where it gets re-encrypted and sent back to the switch, and from there to endpoint 2 of the chain. Alteon service is configured to receive only HTTP traffic, in particular port 443 of the original traffic and port 8080 that is used for the decrypted version of the same traffic. Similarly, Defense Pro is configured here to receive only HTTP traffic, as our goal is to protect a web server. Big Mon allows the reordering of services in the chain with a simple drag and drop. So, for example, the Defense Pro can be moved to sit between the 2 Alteon services to allow it to inspect decrypted web traffic. It is important to also point out that the Defense Pro service actually consists of 2 separate Defense Pro appliances with dirty interfaces from both appliances bundled together at the inline switch as a link aggregation group or lag, and the clean interfaces are added to a second lag we named Defense Pro Clean, so that the traffic directed at the dirty interface of the service will be load balanced across the 2 members of the Defense Pro dirty lags. As mentioned earlier, Radware's Alteon SSL appliance is decrypting and re-encrypting SSL web traffic to create a decrypted traffic zone. If we take a look at the 2 Alteon filters we have defined, HTTPS to HTTP and HTTP to HTTPS, we see that the firings counters are incrementing. And we can also see that there is about 10 Mbps worth of traffic flowing through the Alteon appliance. Big Mon allows the insertion of span services at different points along the chain to deliver copies of the chain's traffic to out-of-band tools. As an example, we will now insert a Wireshark span service to allow us to view traffic on the outside of the Alteon service. As you can see, Wireshark is displaying TLS encrypted web traffic. Let's move the same span service to look at traffic egressing the Alteon within the decrypted traffic zone. As expected, Wireshark is now showing decrypted HTTP traffic with destination port 8080. We can now run a test to verify that the Radware Defense Pro instances are ready to mitigate a TCP/SYN attack within the Bigmon chain. But before we do that, I'd like to take a look at the current state of the two Defense Pro instances. We have roughly 450 kbps of inbound traffic and 2200 kbps of outbound traffic on the first instance. On Defense Pro 2, we see similar rates, which tells us that Bigmon's load distribution based on L3 hashing is up and functional. We also would like to verify that there are currently no ongoing attacks detected on either instances. With that, we are ready to launch a TCP/SYN attack. On the first Defense Pro, we see that a TCP level attack has been detected, and the action taken is to drop the attack traffic. The same action was taken on the second Defense Pro. If we take a look at the traffic utilization report of both instances, we find roughly the same rates of traffic drop, which again confirms successful load distribution, this time of the attack traffic.
Back to you, Bala.
Great, thanks Ted. That was an excellent demo. So now we're going to move on to questions from our audience. And we do have a few that have already come in. Just a reminder, if you would like to submit a question, there is the questions tab available, so feel free to submit a question. We may still have time to get to it. So the first question that we have is for the Radware team. So the question is around the Defense Pro DDoS. So it says, what are the deployment options for the Defense Pro DDoS?
What are the deployment options? Is that the question? I'm sorry.
Yes, what are the deployment options?
Oh, absolutely. So we have multiple different deployment options. We're very flexible here. As I mentioned, the device can be deployed in both transparent and IP mode. This allows essentially a bump in the wire design, or to be deployed in a routed position where traffic is routed through it. So it is very flexible. It can be deployed in symmetric environments as well as asymmetric environments. An example of an asymmetric environment might be like a scrubbing center where you would reroute traffic for the ingress, but egress traffic might not be seen in the same device. And we can also deploy with third-party detection engines such as NetFlow detectors, in addition to our own detection engines of the Defense Pro itself.
Great, thank you. All right, so we have a question regarding the Bigmon product. So this question is, can I have multiple security tools in the decrypted traffic chain?
Yes, absolutely. In fact, as we had shown in the diagram, when we talked about the SSL, Bigmon SSL, Bigmon Alteon SSL solution, you saw that you could chain an IPS as well as a Radware DDoS device in the chain, and you could configure dynamically different chains for traffic to go through one or either or both. I mean, the solution offers great flexibility, and once the traffic goes through these devices, it then comes back to the big mon switch, and big mon sends it. The inline chain is sent to the next one, which is the Alteon device for re-encryption. So essentially, you have this very dynamic and flexible architecture where you could have multiple of these tools in pair with the SSL device, Alteon device.
Great, thank you, Bala. So we have another question that's come in, and the question is, I've invested a lot of money into my current security tools, so can the Radware BSN SSL decryption solution provide clear text visibility to my tools? So who would like to take the question? Go ahead.
Yes, absolutely. I'll take.
Go ahead.
Yes, absolutely. I can take that one. This is David. Yes, the Radware encryption decryption engine can provide and peel off the SSL wrapper, so we could service chain multiple security tools within that decrypted zone. So you could definitely leverage your security tools after the Alteon the encryption engine takes off the SSL wrapper, and then once the inspection has been done, it could be re-encrypted back into its destination. Having said that, another use case that we could potentially have is the outbound SSL, not only for inbound use cases, but also outbound inspection of the inside the data center traffic outbound to a public network to be also inspected on the fly.
Great, thanks. All right, so we have another question, and the question is, if our whole network is based on Juniper, should we have total migration towards Dell HP for big switch solutions?
Well, that's a great question. Actually, if you look at the data center solution that I described, the production network is what we are monitoring, and the big monitoring fabric is actually a parallel network sitting in parallel to the production network. The production network does not have to be a big switch based production network. It could be any network. It could be a Juniper network or any of the existing networks, and the traffic gets tapped or spanned from that network, and it is sent to the big monitoring fabric. And the big monitoring fabric is the one which is composed of the Dell or HP open networking switches managed by the SDN controller. So if your current network is based on Juniper, you could certainly leverage this solution for monitoring purposes with our big mon solution.
Great, thanks. All right, so another question that we've received is, does the DDoS on-premises product integrate with my cloud DDoS service provider?
I think this.
Hey, this is Ben. Oh, go ahead, David. You want to grab that one?
Sure, I can. Yes, absolutely. So the on-prem DDoS solution from Radware can definitely integrate with our own cloud DDoS service. We do have a product for cloud DDoS protection for volumetric attacks. Having said that, other providers also offer these services, so we can definitely integrate, and there's benefits to include our own cloud DDoS, but as well as leverage third-party cloud DDoS service and perform some of escalation actions. So we have an orchestration engine as well that could detect certain DDoS conditions based on rate, bandwidth, prefixes, protocols, and then escalate this the attack and offload it to a cloud. The advantage of using cloud for Radware is that we already have some knowledge of the attack, and then in our cloud we run the same equipment as on-prem, so some of that knowledge is transferred from the on-prem to cloud for seamless mitigation and effective mitigation without a hiccup.
Great, thank you, David. So we're coming up against our time today. If you submitted a question to us and we weren't able to get to it, we will follow up with you individually. And if you have any additional questions today, you can head on over to our website at bigswitch.com, or you can send us an email at info@bigswitch.com. Again, you can view our webinars on demand. And we also make it easy for you to get started with Big Switch Solutions. So there are several resources you can download or watch that will provide a tour of our products. So with BSN Labs, you can experience Big Switch Networks, open networking SDN solutions firsthand. And so, you know, we really believe that there's really no better way to learn about a product or technology than to take it for a test drive. So for a free hands-on experience with our fabric products, head over to labs.bigswitch.com and you can get complimentary access. And all of our past webinars are available for on-demand viewing, and you'll find these on our website at bigswitch.com/webinars. So with that, that concludes our presentation for today. Thank you to our panelists for joining us, and thank you to our audience. We hope that you will join us again in the future.
Thank you.